Hello and welcome to this tutorial on series and parallel networks. If you haven't seen the tutorial on the introduction to electrical circuits, I recommend you go back and have a good look at that tutorial before you proceed to this one, because that tutorial forms the foundation of what we're going to be talking about today. Now we do have a closed circuit with three resistors, R1, R2 and R3, and a battery of V voltage causing a current I to flow in the circuit. Now we can obtain the potential difference across the three resistors by simply connecting a multimeter or a voltmeter to our circuit, well, to each of the resistors, and we can take values V1, V2 and V3. Now this circuit arrangement is what we know as a series network. Some might call it a series circuit, and there are two things that stands out in a series network. Now the first thing is the current is essentially the same in all parts of the circuit. So what I mean is, if you stick an ammeter over here, so if you have an ammeter or a multimeter and you take the current reading here, you're going to get the same reading, the same current reading, as if you put an ammeter over here, or any part of our circuit. If you put it here, you're essentially going to get the same value for your current. So essentially, current I is the same in all parts of the circuit. And the second thing to note is the algebraic sum of the voltages V1, V2 and V3 must be equal to your applied voltage Vs. So I'll just get another color to make it clearer. What I'm saying is, if you add up V1, V2 and V3, it should be equal to your total voltage, to your applied voltage. I hope that's clear. So I'm just going to put this in writing. So what we have is V applied is equal to V1 plus V2 plus V3. And obviously you could extend this to however many voltages you have in your circuit, and you can just add all the voltages up to Vn for obviously n number of voltages, for n voltages. Now we know that Ohm's law states that your voltage is equal to current times your resistance, and therefore we know that V1, so we know that V1 is equal to I, because the current stays the same in a series network. So what you have is I times R1. Your V2 is equal to I times R2, and your V3 is equal to I times R3. So obviously you can use this knowledge to work out you can use this here to work out the formula to find the total resistance in the series circuit. Simply, all you need to do is replace your V by IR. So essentially, you know that V equal to IR, that's Ohm's law. IR is equal to IR1, because we know that V1 is equal to your current times your first resistor, plus I times R2, plus for the third resistor you have I times R3. the current stays the same for a series circuit. And what you have here is essentially R is equal to R1 plus R2 plus R3. And this here, gentlemen, is how we find the total current, the total resistance in a series circuit. I think it's time for us to do a very simple problem involving series circuits. Now, if you go to the second page, you have a circuit with 3 resistors. So if R1 plus R2 plus R3 is 100, find the potential difference across R3. Find the current I flowing through the resistor. Well, we know that the current in a series network stays the same, for any part of the circuit. So the current here is the same as the current here, is the same as the current here. So that should be easy to work out. Determine the value of resistor R2. Well, we don't know the value of resistor R2, so we need to work that out as well. And that is what we're going to do. Now for problem A, for the first problem, find the potential difference across R3. Well, we know that the total voltage in a series circuit is equal to V1 plus V2 plus V3. Your applied voltage is 25 volts, so we have 25 volts. That's a V, by the way. I'll write it properly. 25 volts is equal to V1 is 10 volts plus V2 is 4 volts plus V3. That's what we're trying to find. So this gives us 25 minus 10 minus 4 is equal to V3, and V3 is equal to 11 volts. So for the second part of the question, for the B part of the question, find the current I flowing through resistor R1. So we'd like to know the current flowing across this resistor. So what we do is we go back to Ohm's law. We know that V is equal to IR. So what do we actually know? Well, we do know the total voltage. V is equal to 25 volts. We know that. Current, that's what we're trying to find. And the total resistance is equal to, well, we know that total resistance is 100 volts. 100 ohms. 100 ohms. So what can we do with this? Well, we can say, okay, V equal to IR. So that means I is equal to V over R. And this gives us I is equal to, what's V? 25 of 100. And this should be 0.25 amps. The fact that we know that we're dealing with a series circuit, so we can easily write 0.25 amps is the current flowing in each resistor. So that's basically it for part B. And for part C, what we have is determine the value of resistor R2. So what you have is, we know that, well, Ohm's law states that V is equal to IR. And what do we have? So we know that for this resistor, we know that the voltage is 4 volts. So we have V2 is equal to 4. And we do know the current flowing through this resistor as well, because we've actually worked out the current flowing across the series circuit. So the current flowing through R2 is the same as the current flowing through R1, and the same as the current flowing through R3, and it's the same as the total current. So I'll just put that in writing so that you don't get confused. In a series network, this is really important, by the way. In series network, so your I is equal to I1 is equal to I2 is equal to I3. So we know that I is equal to 0.25 amps. So let me go back to white. So we know that V equal to IR. So that gives us, we rearrange this to make R the subject. So that gives us R is equal to V over I. That's I, by the way. So what we have is R2 is equal to V2 over I2, which is something as saying V2 over I, and this gives us V2 is 4. We have 4 over 0.25, and we have 16 ohms. R2 is equal to 16 ohms. So you can see how we've used the two rules that we worked out here. The current I is the same in all parts of the circuit, which is basically saying your I is equal to I1 is equal to I2 is equal to I3. And the second one is the total voltage is equal to applied voltage. And obviously we can see how we've used Ohm's law to work out how to obtain the total resistance for the circuit. So you can see how we've used that to do some basic circuit calculation, and it's fairly simple so far, so there's nothing too confusing. Next, we're going to talk about potential dividers, which you can see here. Well, this circuit here, and it basically consists of a number of similar elements, basically in a series connection. Well, in this case, what you have is two resistors connected end to end across a voltage source, and here you have an output voltage. So your output voltage in this case is V2. What is V out? So the potential divider formula is essentially V2 over your input voltage is equal to R2 over your total resistance. So that should be R2 over your total resistance, which is R1 plus R2. Well, essentially now we're flirting with a branch of engineering called control, which aims to control the output behavior of a system using what I call feedback control. That's a totally different issue, but potential divider is essentially what you're trying to do. You're trying to measure the output voltage across a resistor, and here we're basically saying that V2 is equal to your V out, your measured voltage. So the potential divider says that the ratio of your output voltage, which is V2, to your total voltage is the same as the ratio of your output resistance R2 to the total resistance. And obviously we can simplify this a bit further to say V2 is equal to R2 over R1 plus R2, and you can put that in bracket. That's a huge bracket. You can put that in bracket, and you can say it times V, which is about bringing this V to the other side. And we're just going to write this down in a more, well, in control engineering form, which is going to get another color here. So what we have is V out, that's your output voltage, is equal to R2 over R1 plus R2 times your input voltage. An example of the application of this circuit potential divider theory is actually in an instrument called a potentiometer, and I have gone to the Wikipedia page and copied an image of a potentiometer, and I'm gonna try and paste it. Okay, here it is. I'm just gonna make it slightly bigger. So this is a potentiometer, and as the name implies, a potentiometer is an adjustable voltage divider. And a more practical application of a potentiometer is actually in audio control. A potentiometer is essentially a 3-terminal resistor with a sliding contact that basically forms an adjustable voltage divider. And if only 2 terminals are used, then it might act as a variable resistor, and we haven't talked about variable resistors, but we are going to do that later on. Now we're going to do a simple problem involving potential dividers. So well, I can't be bothered to actually redraw a circuit, a potential divider circuit. So we're just gonna say here the value of R1 is 4 ohms and the value of R2 is 6 ohms, and your input voltage is, so your V is let's call it, let's say 50 volts, 50 volt. And the question is calculate the value of V2. So V2 again is the output voltage, so the question is what is V2? So using the formula, the potential divider formula that we've already worked out, we know that V2 is equal to R2 over the total resistance multiplied by your input voltage. So we have V2 is equal to R2 is 6 ohms, 6 over 6 plus 4, 6 plus 4 times your input voltage, which is 50. And obviously this gives us 6 over 10 times 50, and that should be around 30 volts. And if you're thinking, well, there's definitely another way that I could have worked this out, you're probably right. Actually, not probably, you're definitely right. You could have used the method that we used in the previous page, which is say, okay, you want to work out V2. What do we know? We know that the input voltage is 50 volts. 50 volt. We know that the total resistance is equal to, well, we know R1 and R2, and so it's equal to R1 plus R2, which is equal to 4 plus 6, which gives us 10. And what can we do? Well, we know that the current in a series circuit is the same anywhere in the circuit, so we can just work out the current, which obviously we know that Ohm's law is Ohm's law states that V is equal to current times the resistance. So we can say, well, current is essentially voltage divided by resistance, and this gives us, well, voltage is 50 volts over the resistance. The total resistance is 10 ohms, and this gives us 5 amps. And we can now proceed to work out V2. So again, we know that V2 is equal to I times R2. Well, we do know what R2 is, 6 ohms. So we know that R2 is 6 ohms. And we know that V2 is what we're trying to work out, sorry. And we know we already know what I2 is. Don't forget, I is the same as I in a series circuit. The total current is the same as the um the individual current flowing through your components. So I is equal to I1 is equal to I2 is equal to whatever I's we may have. So you can proceed to work out V2, which is essentially 5 times R2, and we know that R2 is 6 ohms. 5 times 6 gives you 30. This is obviously another way, well, a longer way to work out V2 if you don't want to use the potential divider formula. But I do insist you understand the potential divider formula because it's really important. Now, on the next page, we're going to talk about parallel circuits, and here we are. So, in a parallel circuit, which is the configuration that we have here, there are two things that we must understand. The first one is well, the sum of the currents I1, I2, and I3 is equal to the total current. So essentially, we're saying your total current is equal to the sum of I1 plus I2 plus I3. Now, the second thing that we must understand when it comes to parallel networks is that voltage, so V, so we're saying that the voltage here is basically the same across each of the resistors. So what we're saying is voltage input is the same as V1, which is the same as V2, which is the same as V3. Now, we know that Ohm's law states that V is equal to IR, and obviously this means that I is equal to V over R, and well, we can now say that I1 is equal to V over R1, and I2 is equal to V over R2, and I3 is equal to V over R3. We're trying to work out an expression for the total resistance in a parallel circuit. I1 plus I2 plus I3 is equal to your total current. So we can rewrite this using Ohm's law. So we can say V over R, so your total voltage over your total resistance is equal to I1, which is essentially V over R1. So V over R1 plus your I2, which is V over R2, V over R2 plus V over R3. And now all we need to do is to divide throughout by V, and what we have is 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. For the special case of two resistors in parallel, so try yellow. So for the special case of two resistors in parallel, so what we have is 1 over R is equal to 1 over R1 plus 1 over R2. your total resistance is essentially R1 times R2 over R1 plus R2. And so for the special case of two resistors in parallel, this is known as product over sum formula. I think that's how you spell it. So now we're going to jump over to a problem involving parallel circuits. So essentially we have a parallel circuit configuration here, and we're asked to find the value of the input voltage. So we want to know the value of V and the value of the total current. So we'd like to know the value of the total current given that I2, so given that the current flowing across resistor 2 is equal to 3. And so for part A, all you need to do is understand that for a parallel circuit, the voltage across the circuit stays the same. So the voltage is equal to V1 is equal to V2 is equal to V3. Okay, so to calculate the voltage, we can use Ohm's law. We know that V is equal to IR, and so we have the current I2. So we know that I2 is equal to 3, and we also have R2, and we know that that's 20 ohms. So that means your V2 is equal to I2 times R2, and this gives us V2 is equal to 3 times 20, and I think that's 60. So we get 60 volts, and obviously we know that your V2, well, your input voltage is the same as your V2, which is the same as V1, which is the same as V3, which is equal to 60 volts. And that is part A done. Now for part B, well, there are two ways to actually obtain the value of the total current. And well, again, we know that Ohm's law is equal to V is equal to the current times the resistance, and we can rearrange things to rearrange Ohm's law to get voltage over resistance. Well, the value of the total current, we can actually start by writing down the formula for obtaining the total current in a parallel circuit, and that is your total current is equal to I1 plus I2 plus I3. So I1 is equal to, actually I'll use another color to work out I1. So let's go back to white. I1 is equal to V over I1, and that, well, we already worked out the input voltage as 60 volts. So what we have is 60 over R1 is 10, so that gives us 6 amps, and we know that I2 was actually given as 3 amps, so we don't need to work that out. So I3 is essentially V over R3, which is 60 over 60, and that's equal to 1 amp. So what we have is the total current is equal to I1, which is 6, plus I2, which is 3, plus I3, which is 1, and what do we get? We get I is equal to 10 amps. And well, another way to actually obtain the total current, so I'm just going to call it method 2, is well, you know that the total resistance for a parallel circuit is essentially 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So we can say 1 over R is equal to 1 over, well, R1 is 10, so 1 over 10 plus R2 is 20, 1 over 20 plus R3 is 60 plus 1 over 60. That's plus, by the way. Plus 1 over 60. Let's continue over here. So we have 1 over 10 plus 1 over 20 plus 1 over 60 is equal to 1 over R. And that gives us 1 over R is equal to 10 over 60. So that means R is equal to 60 over 10, which gives us your total resistance is equal to 6 ohms. And now that you know the total resistance, you can use Ohm's law, which is V equal to IR. So we know that I is equal to V over R. Well, we know that V is equal to 60. We know that R is equal to 6 ohms. So I is essentially 60 over 6, and what we have is I is equal to 10 amps. In method 1 we got 10 amps, and method 2 we got the same 10 amps. So whichever method you choose to use, you should arrive at the same answer. And if you don't, then there's definitely something wrong somewhere and you need to figure that out. Now for the series circuit, we talked about potential dividers. For the parallel circuit, we're going to talk about the current division. You have two resistors connected in parallel. With an input voltage V and a total current I. So we know that RT is equal to 1 over R1 plus 1 over R2, which essentially gives us, RT is equal to, so now you can use the product of a sum because you have two resistors in parallel. So you should have R1 times R2 over R1 plus R2. Well, we know that V is equal to I RT, so we know that the total voltage is equal to the current times the total resistance. Well, we already worked out the expression for the total resistance across our parallel network, and well, we can rewrite this equation here as I times what we already obtained for the total resistance. So that would be R1 R2 over R1 plus R2. So like I said, we want I2 to be our output current. That should be it too. And so again, Ohm's law, we know that V is equal to I2 R2, and that means I2 is equal to V over R2. And well, we've already worked out V, so here we already know that V is equal to this whole thing. So we can easily, well, first of all, let's separate this. So we know that um, I2 is something as 1 over R2 times V. So now we can just put this whole thing in green into V, and that gives us 1 over R2 times V. So if this whole thing goes in here, we have times R1 R2 over R1 plus R2 times I. And obviously you can just cancel the R2, so what we're left with is I2, the current flowing across resistor 2, is essentially R1 over R2 plus R2 times I. If you want to obtain the current flowing across the resistor 1, so you can obviously say, well, I1 is equal to V over R1, and you already know what V is, so again you can take the V and substitute it in here. So this gives us I1 is equal to 1 over R1 times this whole thing in green, so times, it's going to use a square bracket this time, R1 times R2 over R1 plus R2 times I. And obviously the R1 can, actually let's try another color, let's use green. The R1 can cancel out, and we're left with I1 is equal to R2 over R1 plus R2 times I. So I suggest you try this out for yourself and make sure you understand current division and how to derive the formulas for I1 and I2, and obviously make sure you understand voltage division as well. Well, for the voltage division, I think it's all the way up here. Well, I did not actually derive the expression for the output voltage, so I'd like you to try that at home by yourself. And if you still find it difficult and you think you can't do it, well, you can comment below the video, you can inbox me, you can tweet me, you can Facebook me, and I'll definitely get back to you. That's the end of the video. See you soon.